Your building can look perfect and still collapse in real life because you didn't apply real world loads. Today, I will show you how professionals apply load in Autodesk Robot. So, your structure doesn't just look good, they stand strong. I am Dianga Bertrand-Timbo, a practicing civil engineer. If you are a student or intern, this lesson is your shortcut to mastering what universities often skip: how to model real-world forces like dead loads, live loads, and wind loads, step by step. You will finish this video knowing what professionals do on real projects. Before you place any loads, you need to know what and why you are loading. In robot, the most common are dead load, which is the self-weight of the building itself; wind loads, which are forces from nature; custom loads like snow equipments in factories. Example: think of a structure like your working table. The table itself is your dead load. Your computer, phone, mouse on it is a live load. The next part of this video is applying load on your members. Now we are going to apply loads to real elements. Let's now model this in robot. Go to the upper part of your screen, click on loads, navigate down to load types, define your load cases. On the nature, we are going to define our dead load, which is DL1, and it's a structural load, and we'll just allow the name to be DL1. Next, we are going to change our nature of loads to live loads. So we click on dead, you change it to live. We are going to use residentials where it's category A on Eurocode. I will make sure the name is LL1. Click on add. You need at least 2 loads to start, so we can click on close. Always keep your naming clean. Engineers love neatness. Now we are going to apply the dead load on the structure, and remember we said the dead load is the self-weight of the structure. Click and select your whole structure. Navigate down to load definition. Click. We are going to add the self-weight, which is self-weight and mass, and we are going to make sure that up here we have the load set to DL1. So you click here and select DL1. Click on self-weight and mass, and we are going to choose the self-weight on selected elements. Okay, we have been prompted to choose sequential for loading story, but here we don't have stories, so you just click on add. Then we are going to apply to all the members. Close. So robot is going to take into account the self-weight of this structure. The next kind of load we want to apply is the live load on the building, and to do that, the live load acts on the slab, which is transferred to the beam and then to the column. So we are going to click on slab, then come down to load definition. For slabs, we are going to choose the surface load, and we're going to use the uniform planar load. So we're just going to click on it, and take note, we are working on the z-axis. So put a negative in front of your value when working. So we are going to use a live load of -2 kilonewton, and we are going to make sure that we change from dead load to live load, because the dead load is the self-weight of the slab and the live load, which is -2. And we are going to ensure that here we have set it to live load before applying. We are just going to click add, and the slab load is 27. So we are just going to apply. As you can see, the load has been applied. So you are going to click on close. In residential buildings, beams usually carry the wall, which are part of the loads on the beams and not the slab. So the walls are actually permanent loads on the building, so we call them dead load. So we are going to navigate here and make sure we are at dead load. We are going to click on beam, then we right click and move down to select similar. We are going to select similar by member type. So as you can see, all our beams have been selected. Now navigate to load definition, and the type of loads that we put on our beam are uniform loads. So we navigate to member, click on the uniform load, and we are going to apply a load -5 kilonewton for the walls. So we are going to click on add, apply, and as you can see on your screen, the load has been applied. We're going to click close. Now we define what engineers call load combination to simulate how loads act together. Navigate to loads, and you are going to see there are 2 types of combinations: the manual combination and the automatic combination. We are going to go with the manual combination, so click on OK, and we see that robot has given us the permission to start with ultimate limit state. So we are just going to click on all the elements, the dead load, live load, and click on this. Robot automatically detects that our dead load has a factor of 1.35 and our live load a factor of 1.5. Then we are going to click on apply. X type of our load definition is serviceable limit state. Click on new, change the combination type to serviceable limit state, then click OK. Select your loads by right clicking and send the load to the list of cases here. As you can see, robot has given us the factor of dead load as 1, live load as 1. So we're just going to click on apply. Once done, click on close. Now way to do our combination is to choose the automatic combination, and here you just have to define the code. For example, by L you might need the Euro code, and for this case we're using the Euro code. So you click on OK, and with that you have automatically set your combination, and robot will do the rest. Now your building feels the real world pressure just like a true project. The next video we will analyze how your structure reacts, stresses, bending moment, and all that. That's where real magic begins. If you found this easy, imagine doing a whole project with me. Like, comment, and subscribe, and don't miss the next video in the series.